All right, number 11. We want to find the average rate of change from 2 to 7 for this given function, and then we want to find an equation of the secant line containing the points 2, 2, and 7, 7. All right, so right now we have the linear equation f of x equals 7x minus 1. Okay, so with this function, we want to find the average rate of change. Average rate of change is just the slope. That's another name for slope. So in this equation, we can see the slope is 7. If we had a different function like a quadratic, we'd have to actually apply these properties, but I want to show you how you would work it out and see that you still get 7. So from 2 to 7, so we're going to find f of 2. This is my x value. When I plug in a 2 here, 7 times 2 will give us 14. So 14 plus, or minus 1 actually. 14 minus 1 will give us 13. So we get the ordered pair 2, 13. So this is what we get from 2. And now we're going to use the point 7. Okay. So f of 7, so x is now 7. If we plug a 7, 7 times 7 is 49. So we have 49 minus 1, which gives us 48. So we have another ordered pair, 7, 48. Okay. And using these two ordered pairs, we will find the slope. So slope formula is m equals y2 minus y1 divided by x2 minus x1. Okay, so this is my second point. So this is x2, this is y2, x1, y1. All right, so we're going to plug in, this is a y, looks like an x, y2. All right, so we're going to do 48 minus 13 on the top. And then for my x2, x1, 7 minus 2. And we will get 35 divided by 5, and that gives you 7. So that's your average rate of change, which is just your slope. Sorry, run off the paper there. So 35 divided by 5 just gives us 7. That is my rate of change. Now we want to know the equation containing these 2 points. So this is x is 2 and f of 2, which we've already computed, was 13. So since this is a linear equation, and the same thing here, x is 7. When you plug in 7, you get 48. So these are the two ordered pairs they're referring to. Since this is a linear equation, these same 2 points already came from the equation. But if you were to do point slope form and use one of these points, so let's remind ourselves what point slope, y minus y1 equals m times x minus x1. If you were to use this point slope form and use any one of these 2 points, you would still end back up with this equation. Okay. And so we're going to write this whole equation down because it's linear. We don't actually have to work it, but that property will hold. So we're going to write y equals, for our equation, 7x minus 1. Those 2 points will be on that same line. Okay, number 12, we have this function. We want to determine even, odd, or neither. and then find their local minimum, or they tell us there is a local minimum of negative 250 at negative 5, determine the local maximum. Okay, so we have the function g of x equals negative x cubed plus 75x. And we're going to determine first even, odd, or neither. Okay, so g, say, of negative x, that will give us a negative x cubed, and then plus 75 times negative x. Okay, so 3 negatives will come out negative, and then a negative times a negative will come out positive. So we will have a positive x cubed, and then here this will just come out to be a negative 75x. So this is what we get for g of negative x. These do not match. This has a negative x cubed, this has a positive. So just based on those, these do not match, so it is not even. Put an x by even. It's not even. Okay, so now we're going to find negative g of x. Negative g of x just means we're going to put a negative on the outside and distribute a negative to our original problem. X cubed plus 75x. All right, so we would distribute this negative through. And so negative g of x would give us a positive x cubed, and then that will become a negative 75x. So you just distribute this negative as if it was a negative 1, and this is what we end up with. Okay, these two equations match, so this is odd. This function is odd. Now, based on that, we can now figure out if there is a local minimum. So they tell us a local minimum. What is the local maximum? Okay, so this is what we need to know. If the function is even, we know this. We start out with our original function, so original ordered pair, we'll call it x, y. What we do to determine if it's even is we compare it to making x negative. So if we know that it's even, if x, y is a point on the graph, for example, let me plug some numbers in here. If 2, 3 is on the graph, then I also know, because it's even, that negative 2, positive 3 is also on the graph. Or negative x, let me put it in notation first. Negative x, if you change the value of the x, the sign of the x to negative, this point is on the graph, and therefore this point, negative 2, positive 3 would be on the graph. If we know it's even, all we do is change the x value. That's what's happening here. So comparing these two, comparing this original to this, all we did was change x negative. Now, when we confirm that it's odd, we're changing both. X is negative, and on the outside, y is negative. So what this means to be odd, if we know that x, y is a point on the graph, we also know that negative x, negative y is a point on the graph. So same scenario, if I know that 2, 3 is on the graph, I therefore know that negative 2, negative 3 is on the graph. This is a property of what it means to be odd. And since we know that we have a minimum, so I don't know what the graph looks like, But I do know somewhere over here we have a minimum, and this is a -5, -250. Furthermore, I know that if I change these values, I will have a +5, +250. This is just a property we get from symmetry. Since this is a minimum, this should be a maximum because everything should match. So maybe the graph is doing something like this. I don't know exactly. Okay, but something to that degree. And this is what we know. So we have a local maximum is 250. That's the high point because of the property.